So let's move on. Expectation. So we have all this data, and instead of like the number of pieces of data, we have probabilities attached to the data. So we still want statistics? Can we still find the average, the mean, the mode, and like the standard deviation, the variance? Can we still find that on the data, even if it's just connected to a probability? When we think about it, the answer is yeah. So first of all, what is the average? Of like 1 to 6. And you say, so for example, these are like the outcomes of rolling a die. And you say, okay, 1 plus 2 plus 3 plus 4 plus 5, 4 plus 5 plus 6 divided by 6, that's the average. But if you notice, I can break this up in as, 1 divided by 6, 2 divided by 6, 3 divided by 6, 4 divided by 6, 5 divided by 6, and 6 divided by 6. And I can write this even more, like 1 times the 6, plus 2 times the 6, plus 3 times the 6, plus 4 times the 6, plus 5 times the 6, plus 6 times the 6. And you notice that the average is actually the outcome times this probability, right? Because the probability of getting a 1 is a 6. The probability of getting a 2 is a 6. And so if we add these up, this is the average, but we're going to call it we're going to use the notation of E of x, and we're going to call this the expectation. And the idea here is based on the probabilities of events happening. What should we expect? It's theoretical, but so on average, it's 3.5. So in this case, the expectation is 3.5. And the idea is it's literally in the center. So what is the center of 1, 2, 3, 4, 5, 6? The center is 3.5. That is the expectation. This is a mathematical idea. Sorry, let me lower the screen. So we have this idea of expectation. It's the sum of the outcome times its probability. And so we can take an example. For example, let's say that there's a distribution, and it's and the probability connected with it. Okay, and let's see, it's 1, 3, 6, 8. The probability of getting a 1 is 0.2. The probability of getting a 3 is 0.4. The probability of getting a 6 is 0.3. And the probability of getting an 8 is 0.1. So we would find the expectation. Once again, we don't know how many times this occurred, but still we know that 1 occurred 20% of the time, 3%, 40% of the time, 6 occurred 30% of the time, and 8 occurred 10% of the time. The question is, what would we expect? So the expectation is 1 times 0.2 plus 3 times 0.4 plus 6 times 0.3 plus 8 times 0.1. And that's the idea of the expectation. So what do we have here? 0.2 plus 1.2 plus 1.8 plus 0.8. Let's see, 1, 3, 4. The answer is 4. So although the outcomes are 1, 3, 6, 8, we would expect kind of right here a little bit closer to 3. So the answer is we expect 4. Okay. Couple of other things we want to talk about. So we can find the mean, or you should know this as the mean. The average. That's the idea. Couple of other things though. So let's see. What do I want to talk about here? So a couple other things. So let's talk about what happens if we, let's talk about, what happens to the expectation when we change the data. So for example, I want to look at, AX plus B. So the idea is X is my outcomes. I want to know what happens when I transform it. So let's make a chart. So for example, let's call this, let's C, D, E, F. This is the outcome. This is the X. And the probability of these outcomes is G, H, I, J. Okay? So the expectation is equal to CG plus DH plus EI plus FJ. Fine. What is the expectation of X plus B? So you say, okay, well, let's see, it's C plus G, not B, sorry. Oh, well, the B. C plus B times the G. So we're changing the data, but the data is still connected to the probability. So it's C plus B times G plus D plus B times H plus E plus B times I plus F plus B times J. All right? So what's going on here? Well, let's see, I have CG plus DH plus EI plus FJ plus B times G plus H plus I plus J. Well, this is the expectation of X. What's going on here? Well, G plus H plus I plus J, that's a distribution. That's 100% plus B. So when you shift the data over B, or you increase or decrease it, the mean increases or decreases by the same thing. Let's try another one. How about we do, now let's multiply it by A. So EAX. Once again, I'm taking all my data and I'm multiplying it by A. It's still connected to the probability. So let's see what's going on here. The expectation is AC times G plus AC times H, T, plus AE times I plus AF times J. Well, what am I going to do here? Let me just pull out the A. Let me just factor out the A. And I'm left with CG plus DH plus EI plus FJ. And that's simply A times the expectation of X. So when you multiply all the data, multiply everything by A, you multiply the expectation by A. And then we can conclude, let me just get a new pen, this has run out. Therefore, we can conclude that E times AX to the B is equal to A E of X plus B. Couple of other things. What is the expectation? What is the expectation of, just a letter? How about like I don't know. Well, the B is constant, right? So what is the expectation of B? Well, you're taking the average of B's. So let B, where B is a constant. Well, if I have B plus B plus B plus B divided by N, it's still B. The other thing you want to know, what else do we want to know? The expectation of, in this example, of e to the x squared. Well, it's simply, all we're doing is just multiplying, we're squaring the data and multiplying it by its probability. Let me move the screen over. Let's see, so we have d squared plus h plus e squared times I plus f squared times j. What else do I want to talk about? Let's see. And that's based, okay. Sorry. Let's continue. So this is how we find the expectations. This is the average. So the question is, we have the expectation. The next thing we're interested in is the variance. What is the variance? Well, hold on, my pens are running out. Sorry. Let's try another pen. How do we find the variance of data? So we have a data. Once again, let's just come back to the beginning. We have outcomes that are connected to probabilities. Let's think about how we found the variance, originally. So let's think about this. How did we figure out the variance? So the variance of data was, if you recall, it was the sum of, we took the mean, we took a data point, we subtracted the mean from it, we squared it, and divided by n. Okay, so the question is, I keep saying expectation and mean are the same thing. So we're gonna understand that, let's write down the side. If we see the sum of a number divided by n, that is the mean. This is the mean. Or rather, this is the expectation of x. So let's see what's going on here. Now, am I going to ask you to reproduce this on a test? Is I going to ask you? No, we're just going to derive it. So what's going on with but you are going to be asked the variance. So what's going on here? Well, if we have the sum of, let's expand this out. We have I squared minus, what do we have here? We have 2 mean individual data points plus the mean squared over n. Okay, let's break this up. So the summation of 1, 2, 3 terms is the individual summations. So we have the summation of the individual values squared over n, right? Minus the summation of 2 mean individual values over n plus the summation of the mean squared over n. Okay, so I'm doing this because this confused me, and I probably doing more for me because I want to get this out. So what's going on here? So let's take a look at this first one. This one says the individual data points are squared, they're added together, and then it's divided by n. So this is like the average. So this is another way of writing the expectation, the average of all of the data points squared. This is ex squared, right? That's what's happening here. I originally squared all my individual points. They're not the same, they're all different. I squared all of them, and then I divided by n. Well, once again, that's the expectation of the data points squared, okay? What's going on here? Well, first of all, this mean, if you recall, that's fixed. That doesn't change. So I'm going to pull that out. I'm also going to pull that 2 out. And so I have the summate, sorry. So I have x squared. I have 2 fixed mean, right? It's not changing. Like here, these are different numbers. This is fixed. Summation xi over n, okay? And then we'll get to this in a second. We'll hold off on this. I'll write it again, just to keep the lines. So this is done. Let's just keep moving down. Well, what's going on over here? Well, okay, first of all, this x mean, this is the mean. So it's expectation of x. And then this, by definition, is, once again, the expectation of x. It's the mean. What's going on here? What is going on here? Well, I want you to think about this because this always confused me. I'm like, how do I explain this? Well, what do we have here? We have the mean, the fixed mean, squared, and I'm adding up a bunch of these. n times, right? There's n of these. This is n terms. And then I'm taking the average, which equals what? So this equals n times this mean squared. But if I want the average, I'm divided by n. This equals the mean squared. But the mean squared, another way of writing this is e to the x squared. So I have e, the expectation of all the data squared, minus 2 times the expectation squared plus the expectation squared, and I get this really cool formula for the variance. The variance of my data given, like outcomes that are connected to probabilities are the expectation of x squared minus the expectation squared. That's how we derive it. I'm never ever going to ask you that again, but you might see a professor doing it. So let's take an example and find the expectation and the variance, and we can make up our example. Let's go back to let's use the example that I had. So we had x, and we said it was 1, 3, 6, 8. Okay, let me move the screen over, sorry. And we said that the probability distribution was 0.2, 0.4, 0.3, and 0.1. And so what we want to do is, like all data sets, like some of you are taking biology and all your science classes, you want to find the average and you want to find the variance. What you'll see in physics, I think the idea is that events are connected to probabilities more and more. I could be wrong. So let's do once again the expectation. We found the expectation. What did we say the expectation was? Let's do it again because I forgot. Let's see. We have 0.2 plus 1.2 plus 1.8 plus 0.8, 2 and 3, it's 5. 3 and 1 and 4. The expectation was 4. Okay, now let's find the expectation of the data squared. A little different. So we have 1 squared times 0.2 plus 3 squared times 0.4 plus 6 squared times 0.3 plus 8 squared times 0.1. Let's figure this out. 1 times 0.2, 0.2. 9 times 0.4 is 3.6. 36 times 0.3 is, I believe it's 108, so it's 10.8. And 64 times 0.1 is 6.4. So we have, let's see, 0.2, 3.8, 13, 14.1, 20.5. Therefore, the variance of x, the variance of our data, and we understand variance, is, let's see, so it's 20.5 minus 4 squared, which is equal to 4.5. So on average, the data is 4.5. 4.5. Well, the variance is 4.5. We know as the standard deviation. So what's the standard deviation? Well, that's easy. That's simply the variance of. So hey Siri, what is the square root of 4.5?
The square root of 4.5 is 2.12132.
So on average, the data is 2.12 away from the mean or the center. And that's the idea of, I think that's everything I wanted to cover. So the exercise is just going to be very simple. Like you're going to be given the distribution chart. One thing's going to be missing. You know the sum of the distributions have to equal 1. You fill it in, and then you can figure out the expectations. So the expectation squared, you can figure out the variance. You also might be asked to transform the data. The other thing you need to think about is, can we transform the variance? What happens when we transform the variance? So let's see about that. So the question is, what is the variance of ax plus b? It turns out to be, I'm just going to tell you, it ends up being, you can prove this on your own, it ends up being a squared var x plus b. And that's the idea, because it squares everything. You know that from your variance. This is the answer. It might show up something to think about. Anyway, that's good.